Okay, continuing with this section, we're going to combine like terms. So a term is a number, a variable, so let's fill that in, or a product or quotient of numbers and variables. Pause that to make sure you get this written down. So again, a term is a number, for example, like 3, a variable, for example, y, or a product, meaning multiplication, of numbers and variables. And it says quotient because you could take these and divide them. And these are terms because if they were written together in one line, you would see them separated by addition and subtraction. If I had something like 4x3y, I might turn that into 12xy, but that would all be one entire term here and one entire term here. Like terms are terms that have the same corresponding variables and powers. Since I'm working on an iPad, this is a little bit difficult to get those into both blanks, here and here, but try your best to write that in neatly in those spots. Also with powers, let's tag this, drawing an arrow to it, because a power is the same as basically saying an exponent. So like terms have the same corresponding, so this x could have a 5 in front, this x could have a 3 in front, and these would be considered like terms because they have matching variables, and they also have the same power, which would be 1. If this said 5x squared, while the other said 3x, these would not be like terms. They do not have the same power. If this said 5x squared and 3x squared, these would be like terms. If the variables were different, where one said 3y squared, while the other said 5x squared, these would also not be like terms because x and y are different variables. I'm going to move in and zoom and clear everything out so you can see better focused on what I'm talking about. So I'm going to get the zoomed in steps to take up as little room as possible. I mean as much room as possible so I can write large, excuse me. Okay, so these problems always say simplify each. And sometimes you'll find that you have a term separated by a plus, separated by another, and so on. And you'll find that you can only go from having 4 separate terms to 3 separate terms. And what's weird about that is if I had 4 quantities and went from 4 to 3, that wouldn't feel like I simplified all that much. But even though that feels weird, that's sometimes all you can do. Okay, now let's look at this first one where it says x plus 4x. I'm going to write it over again, and I'd like you to do the same, just so that you know that when you get this into your textbook, get it from your textbooks into your notebooks or loose leaf, when you're rewriting these, make sure that they get written accurately. So this is x plus 4x. The first step would be, well, what variable is earliest in the alphabet? And when I look at this problem as a whole, I only see one term and a second term, but I scan from the left to right with my eyes, and I only see the letter x. So earliest in the alphabet would be x. Well, what are the powers? Well, this has a degree of 1 on it. That has a degree of 1. So there's nothing unique there. There's only 1. Do they match? Yes, they have the same letter. They have the same power. Then we can circle all the like terms. So go through, for this one, circle them. I will not have you do this for latter problems, meaning problems that follow. We circled all the like terms, combine those, then move on to other letters. So if I had y in this one, the other letters I might deal with would be y. And then lastly, constants. A constant is a number like 4, 5, it doesn't matter. So tag this, draw an arrow to it, and write like the number 4. It's just a number detached from a variable. In front of x, it's the same as having 1x, so if you prefer to see it that way, go ahead and write that, but I've written it in red, meaning that you don't have to. And then I have x plus 4x, which when combined gives me 5x. We went from 2 terms down to 1 term. This is simplified. If you feel like it, you can make this an OYO problem, meaning on your own. You may pause the video so that you give yourself time to work on that. I'm going to talk about it thoroughly either way. I'm rewriting it here. It's helping me think about it. I see only the letter H. I know that because they have the same power, I can combine them. And I also know that 8 minus 4 is 4H. You'll notice that I didn't circle them this time. The reason I didn't circle them is because as I work on these problems, if I have circles here and then a box here, I'm sort of polluting my picture and making it a little bit more hard to navigate. But that being said, feel free to circle them so that you can see that they match up. This is 8, that's minus 4, so that would be 8 minus 4 giving me 4. Let's check out more examples. You'll notice that there might have been a second part of the instructions in your textbook. You might notice this later, where it says simplify each. If it is already simplified, write already simplified. So I'm going to see if I can zoom in without rotating, hopefully, and bring this next problem up. This problem says 8m plus 4. Well, I see a variable of m, and then I see nothing after the 4 here. So although you might want to try and say that this is 12m, this is completely not true. 4 is a constant. Because 4 is a constant, I could only add 4 to something else like 3, but I couldn't add it to something like 3y because these are not like terms. Because this is already the way it is, in your textbook, when you see something like this, you'd rewrite the problem like I have, and then you'd likely throw a semicolon because the semicolon communicates, here is 8m plus 4. By the way, this is already simplified. Make sure you have that written down like I do. You'll notice I am now over to the right. I did not move downwards because this one is not quite as intense as the problem to the left and this one underneath. All right, so we'll rewrite this. 5k plus 3k plus 12. If I follow the steps, I'm thinking to myself, okay, I'm scanning through the entire problem. Do I see any variables? Well, I see k, and I see another k. So I have 2 things that can be combined. This does not have a squared, while this would have a 1. So because they are the same, I can match them up and consider them to be like terms. 5k plus 3k gives me 8k. 12 is the only constant, so I cannot combine 12 with 8k. Even if I could, I would not do it in that step. So I box 8k plus 12, and I'm done with this. If you wanted to count rewriting it, this is really just a 2-step problem where you rewrite and then secondly bring it down. Let's take a look at the much more challenging ones in the next row. 15 minus x squared plus 4x squared. I'll rewrite that. I see 15. I see something with a variable, minus x squared. I see something with another variable, plus 4x squared. And then I see a constant of minus 10. Well, on purpose, I've already color-coded this. But if you wanted to, you could draw shapes around this. Well, the earliest in the alphabet letter would be X, and it's also the only letter in the alphabet. And if you drew a circle around this, make sure that it's clear to you that this minus is attached to the X. If you draw a circle around the 4x squared, you can just circle 4x squared. And then since we're actually given 2 extra terms that match up, you'd want to choose a different shape. So I box this, and although there's not a positive in front of 15, I know it's positive. And then I box the minus 10. But I've gone ahead and I've drawn these in different colors to make them match up. Now that I've drawn them in different colors, I will show more steps than you'll later need. You can cut this step out later. I'm going to rewrite the variables first. I'm not going to combine them. I'm just going to rewrite them. I see minus x squared. I want to rewrite that far to the left. I see plus 4x squared. I want to rewrite that also far to the left. The reason is because now that I've written it there, I'm getting it in the correct order for how to combine these. Then I have 15. Nothing should disappear, and I know that that is plus 15 even though there's no plus sign in front of it. And then lastly I have minus 10. When I go to combine negative x squared plus 4x squared, remember that if you have a difficult time with integers, you're not learning integers now. You're not learning about negative numbers. You are learning about combining like terms. So you want as much of your thought designated to combining like terms, and all of this side thought, you want a minimum amount of thinking about integers. And I point that out because if you have to really think at a high level about what negative 1 plus 4 is, then you're going to want to use your calculator as a tool. So if that's you, get a calculator out and type negative 1 plus 4. Because for somebody really fluent in integers, you can just jump and say, well, that's 3x squared, and I'm done. And I knew I could combine those because here's 2 and there's 2. 15 minus 10 gives me 5, so I'll show plus 5. And I box it because this is completely simplified. With these multiple step ones, you may want to pull up Wolfram Alpha and type in the problems. Because if you type the problems in using the caret to raise up to a power, like here would be x squared using that caret, you can type these in and check all of your work. Because if you do 10 problems the wrong way, you're going to find yourself in a sticky situation. You probably want to do one problem the wrong way, double check it, and see if you can revise the way you understand this before moving on. So we walked through how to do the problem. I reminded you of why to use your calculator for integers if you have to, and I'm also encouraging you to use Wolfram Alpha, which you just can Google search, to use as a resource. There it is. It's written. That's an A, not a U, and you can write that down and go to it later. These can get uglier, but they really don't, in my opinion, get all that crazy intense just yet. Let's rewrite it just because it gives you a chance to think about the exponents you write. 3x squared plus 4y plus 5x plus 2x squared plus 2y. Oh man, here we go. Yeah, budget your space well on these. I'm limited with my iPad because I have to write larger. But you might want to do problems that get this lengthy in one entire wide row rather than using like columns for ones that are this heavy duty. The first thing you could make a mistake with is rewriting it. I just looked through mine and I think I'm good. But yeah, where I stopped talking was 2y minus 6y plus y squared plus 8. Okay, looking at this, I see x, I see y, and I see constants. So I see things with x, I see things with y, and I see just regular numbers. Okay, so I look through and I see my x's. One has a 2 attached, another has a 2 attached, and then one is just to the power of 1. So I'm going to deal first with my x squareds. So I will rewrite these in order so that it's clearly lined up. Here's 3x squared. I keep looking. I know I've dealt with this one. And then I see 2x squared. I'm tempted to move on to y, but I still see things with x. So I'm moving left to right, and I stop at 5x, and I keep on scanning. I see nothing else with an x. So I'll write plus 5x, because there was a positive symbol in front of it. I keep on looking. Move on. I see no other x's, so maybe I drop down to y. I see a y, but then I see a y squared. So I'm going to write plus y squared because that's the only y squared I see. I move on. I still have y, and I have 4y, 2y, and then minus 6y. So here's plus 4y, plus 2y, and then make sure you don't forget about the subtraction symbols out front. I look, I see all my x's have been dealt with, all my y's have been dealt with, and that leaves me with just my 8. Now I have these underlined in red because I don't really want you to do that, but you might want to put a little tick mark or something by it if that helps you with knowing that you've already dealt with it. Okay, running out of multiple colors here, so now I'll use something different like purple. Okay, 3x squared plus 2x squared, 3 and 2 gives me 5x squared. I want to combine x and 5x with something, but I can't, so I'm just going to write that. I only have one thing showing up with y squared, so I can't simplify that. And then if you're a addition subtraction guy, you're looking at this and you're like, well, there's 6y, and there's 4 and 2, and I know that 4 plus 2 minus 6 is going to go away. Optionally, if you wanted, you could have written plus 6y minus 6y, and then cross those out. I don't see that as cutting much of a step. I don't think that's cutting a big corner. So I'm going to show that in my work, and my slashes would not be red. They would be drawn, so I will encourage you to go back and add those. So if you showed this as a separate step, then you just have to rewrite it one more time, getting to where you've totally simplified this problem. Now it might look ugly, and it kind of is, but it's not too crazy. I kind of enjoy these. Again, a lot of steps in here. It would be very frustrating to type that whole thing into Wolfram Alpha, but you could. And as a final step, I'm scanning through this just to make sure that nothing else has a 2 and an x. I'm making sure that nothing else has just x. I'm making sure that nothing else has just y squared and that there aren't any constants lingering out there that I need to take care of. Behold the fraction. Well, all of this is just bringing it to the next level up where you're going to have to deal with fractions. So here's 4/5 x minus x plus 6/5. On purpose, there's only x involved, so that you really are focusing mostly on the combining of fractions. Well, back in the day, if you wanted to take 4/5 and add 6/5, you were good to go because these match. But the issue is, this is not in terms of fifths. So we can either convert that now or deal with it later, and let's see what happens if we deal with it later. I'm going to take 4/5 and add 6/5 in that step because I'm not dealing with negatives or anything like that. That doesn't seem too crazy to me. Which gives me 10 over 5 x minus, what if I made this 5 over 5x? Would that save me time or make it more difficult? You might know where I'm heading with this. Let's write 5 over 5x. I've gotten a common denominator. So this says 10/5 x minus 5/5 x, which ends up being 5/5 x. And 5 over 5 is just 1. So I'm not going to bother writing 1x. You can if it helps you. But when you're finally simplifying, box this. Avoid writing 1x. Okay, so here's a little bit of a side thought. We wrote this. What if instead I would have gone from this first rewriting step to combining 4/5 and 6/5 like I did, but then just subtracting x after it? Well, and you simplify in this stuff, you get 2x minus 1x, which ends up just being x. Same result, no big deal. Sometimes it helps to combine like terms. Sometimes it helps to get a common denominator, and sometimes you don't know how the path is going to unfold. So if your path ends up going from here to there to there to there, that's all right, but sometimes there's a shorter path in between. Sometimes taking the shorter path seems like a good call, but then it ends up zigzagging later on in the problem. This is chunked into a couple of different sections, and that's so you can jump back and forth. So get a header on your paper for this first homework, work on it, and then we'll save the second for a different day.